time we've been focusing on discrete random variables, right? We have been focusing on variables that if you had to graph them, let's say you had a coin or you had a die and you had all 6 options, then you could either be 1 or it could be 2 or it could be 3 or it could be 4, it could be 5 or it could be 6, right? You can only take discrete values, right? We looked at working with discrete values and then we looked at the distribution that looks like this, which was the binomial. Now, we're going to continuous random variables now. In a continuous random variable scenario, right? The possibilities or the values could take anything within a range. So for example, if you have a range of values between 1 and 2, right? For a continuous random variable, they could take any value in between here. So it might follow something like that, right? So you might get something like that. It might get a distribution looking like that. So you get a distribution looking like this. This is called a discrete random variable, where you can take any value between here and here. That's okay? Now that a discrete, sorry, now it's continuous, we can't go and do a little table. Remember, we had a problem distribution table. We can't do that anymore. We have to find a next way to find the probability, right? What you will learn or what you will observe is that this area underneath here represents the probability, right? So in this scenario, if I had A and I had B, and I were to integrate between B and A, right? I would say integrate the particular PDF they gave us. So if I were to integrate f of x between B and A, what I will be able to get is the probability in this case, which is 1. That's okay? Because remember, if I take all the possibilities, the probability of all the possibilities is 1. So it means that the area underneath here, this shaded area here, that shaded area is 1. But the good thing in unit 1 is that I don't have to integrate. What it is do, that instead of integrating, what they will do is they'll give you something like this. Right? What they will do is give you something like this. Yeah, so they'll give you a straight line, right? Let's say here, f of x is equal to 2x. Right? F of x is equal to 2x, right? And they might ask you, okay, well, using that bit of information, right? Finding. Okay, so we have a continuous random variable and they want us to find A, right? What do we know? We know that the probability of x, right, is the integral between 3 and A of f of x. That integral is equal to 1, right? But you ready? If you can integrate, that's a way to do it, right? But here's this. Here's what, right? The area is also equal to the probability, right? So what that means, since the probability is 1 over this range, I could find the area in here, right? And this is should be easier. Okay, so it's half the sum of the parallel sides, right, by the height. So the height is 3 minus E. The height is 3 minus E, right? And the 2 parallel sides, I'll get this side here. I'll get the y value. And I can plug A in there. If I plug A in here, I'll get 2 by A, which is 2A, right? And if I plug 3 in there, I'll get 6. So the parallel sides are 6 and 2A. Right? If I work this out, okay, I put 2 here. I'll get 3 minus A by 6 plus 2A is 2. I could work this out. I'll get 18 minus 6A plus 6A Come on, make up a stupid question. Oh God, I make up a bad question. That's two. It's been cancelled. Oh no, I do nonsense. Right, good. 3 by 3 is 6. 3 by this is 6. Minus a by 2a is minus 4. Minus a by 2a is minus 2a squared is 2. This will cancel and you'll get 2a squared is equal to 16. A squared is equal to 8, right? A is the square root of 8. Right? So basically, what I'm trying to say is that we don't really have to integrate. All of that's the rule. We don't really have to integrate. All we have to use is the area being equal to the probability. Okay? And if it's the entire area, right? If it's the entire area, then the entire area is 1. All right? Let's say you wanted to get the probability between B and C now. Then the probability of X between C and B is the integral between B and C of f of X dot dx. Right? Again, we're not too interested in integrating curves and then, right? Just straight lines. Okay. All right, online. So what we have to be able to do now is just basically find the area on the curve, right? Under the line. Copy down. So let's try a few now. Any questions online there? Right? For those who do the pure math, if you want to integrate it, they can check it and see, right? Integrate it now. In fact, try for those who can integrate, try this part here from integrate 2x. It worked out, right? And make up a little math thing here. I get that. Again. Right, I'm on square room. Right, just check it and make sure you're getting rotate, right? And let's open up the like. Oh, print it, like 1 4. And that's fine. That's right. That's what I'm going to Yeah, just integrate the again, the same code, right? Don't give all the chance. Yeah, one next side. Ready? Let's go again. Let's try one there. All right, let's start here. So let's say I gave you something like that. Right? I gave you f of x is equal to 0.2 minus 0.22, right? They want the probability, the delay will be less than 4 hours. Before you do anything, right? You recognize that there's a straight line. It's a straight line, right? It's of the form y is mx plus c, right? So it's of the form y is mx plus. So just do one quick favor, use a little skills on different on sketching, and see if we can sketch up from sketch up between 0 and 10. Sketch up quick. Right? So when we find the probability less than 4, you know what we do, right? Financial plugging. So I'm talking about plugging the value 0, 1, 10, right? See what I get. Huh? Okay, for how far? I mean, from where? From where? Oh, that way out. Oh, okay. Okay, zero. Right, so, yeah, that's too long, maybe. You can see. Yeah, I'm not even- What is what is from Milan, I like one. Right. So I was gonna see what you have, right? I don't have a pen, so I will, there'll be a problem there, but when X is zero, Y is 0.2. Why is it that? Right, so that is 0.2 is about here, and when X is zero, Y is 10. Look at that,
What? I have the meeting.
when Y is zero, when X is zero, I am getting 0.2, right? That's the Y intercept, and then it comes down here. And that's when Y is zero.
Okay, it's 10, yeah.
So in the game. Right, so it looks like that. Y'all got a scale line? Let's pull up somewhere. Bradley, you there? Jaden?
Yes, kinda was,
Huh?
I kinda was.
Oh no, I just tried to draw that line for you. That's a line, right? So I plug in,
Yeah,
plug in X is zero and I plug in X is 10 and so. And I got that line. That's okay? Bradley?
yeah, I guess.
Okay, so that's the line, right? Now they want. Now they want the probability less than 4 hours. So you're looking for where 4 is. Coming up here, and you're finding the area. Are you okay with that one line, Jaden? So they want the probability of X is less than 4. Right, so you have to find that area there. Yeah? So you have to find using trapezium law, right? Try it now. Try those two there. After somebody parallel side now. Try that there online. When you get message your answer. Alina, you okay there?
Yeah, yes, sir.
Yeah, I think I'm missing something here now.
Why am I missing? Tell me. You're listening all the time or you know join? Be honest, huh?
I was listening to some of it, and well, from what I could tell, right, well, we integrating and the boundaries would be 4 and 0 for at least part A.
Right, but you do have to integrate, right? You have to find the
Oh,
area.
I mean, like the integration sign, yeah.
That's what you're doing here.
And the boundaries would be 4 and 0. But then Oh, I guess you had to substitute the 4 and the 0 into each one. And then minus how you would then like after minus how you would when integrating or quote unquote integrating.
Yeah. So you just find any area between 0 and 4. And when you plug in 4, where again you are. Right, so the probability. So the probability of x is less than 4 will be half the sum of the parallel sides, which is 0.2 plus 0.12 by the height, which is 4. Right, so I got 3.32, which is 0.64. Yeah. Right, so the probability is 0.64. Yeah. Okay. If you integrate it, you won't get it wrong.
Yes, what I'm missing is the like how you minusing to get the 0.64 because well when x is equal to 4 it just multiplies 0.2 by 4 I think. And then so what I did right was I multiplied 0.2 by 4 and then I multiply 0.02 by 4 and then I just minus them and I get 0.48.
Right, so
But-
the method I use was, you see that green part there?
Yeah.
That green part is trapezium.
Yeah, so that's where I kind of lost it.
Right. So that green part is a trapezium. So I'm using the two parallel sides. The two parallel sides are. Right, we're not coming forward, hold on.
0.2 and 0.12.
Yeah. I don't like how this looking, right? Watch it. Right? So you have this, right? Sorry. You have this and you have your line. Here is 0.2 and here is 10. Right? They want the probability of it less than 4. So that's this area trying to find it. Right? So I'll join it out. Right? That's a trapezium. I want to find the area. Here's 4. This whole length here is 0.2. But I don't know this length here. Right? So to get to that length, I went across here and I found the y value using the equation. What was the equation again? 0.2 minus 0.02x. So I took 4 and I put 4 in here, and I got 0.2 minus 0.02 by 4, and I got 0.12. So I know that this side here is 0.12, which corresponds to this length here, 0.12. Right? Now I use the formula for trapezium, half the sum of the parallel sides by the height, which is 4. Right? So this is 0.32 by half of 4, which is 0.6. Remember, you can't get a value.
Okay, okay, I understand what you're trying to say. So well, okay. Well,
If you want to use the integration technique, guys, okay, right?
also just one more thing, right? Oh, this was like, well, okay. When you find the y value, you just find in the equation and then you plug in everything in, like the x value, and then you plug in everything in.
Yeah, remember they gave you the equation at the beginning of the question.
This is area under the curve.
Yeah, that area under the curve, yeah. Well,
So,
line.
so I'm allowed to integrate that one?
Yeah, you can integrate if you want to.
Okay.
See why you must pay attention all the time. Bradley.
That's Akamal.
All right, next one. Yes, do the last part from now, please. Find the probability between 2 and 6 hours now. Sorry. You'll do the part between 2 and 6 hours. And we'll cover up.
Yeah, on the
We'll get-
so I think it's
Huh?
gonna be. Well.
No, what do the integration, that is a good solution. I just do it like that. Right, feel free to integrate, right? If you're comfortable with integration, go right ahead, right?
This guy's a.
I'm putting with the fire. So it was. Perfect, so you are. Did you? Anybody next to you, talk about it? Oh.
It's, I might be.
And now tell you can integrate. How long it takes to do it.
So again, 0.48 for the second one.
What you got, 0 point?
48.
That's now I'll tell you. Anybody else get up? You don't need to message the answer, right? 0.48? Anybody get 0.48 again? Right, remember it. Right, since we all do want, since you all do want to find the area, yes, it is. Anybody get 0.48 again? Would I subtract 6 and yeah, you will subtract 6 and 2 for the height. Or length, I want to call it. Right, so it'll be 4 by those two values. 0.48, everybody get that. Right, let's go again. Any questions there? Try this one here. Right, so you usually ask sketch, right? You need to know what that will look like. But real simple, Here's a constant, right? 2 minutes again, I'm gonna do it. All right, let's see. So I want to see firstly if we got the graph correct. So you get a bit of skills in sketching a little graph. Right, I'll do the graph in blue. Right, because it's K is a straight line. Right? Here is your -2 and somewhere lower down is your 3. Okay, so this entire area here is 1. Okay, it's a rectangle, so 1 is equal to 3 and 2, 5 by the height, which is K. So K is 1. Anybody get up? Right? K is 1/5. And this part here, we integrate in 1/5 between 2.1 and -1.6. That's it, we done. Okay. It's a straight line, right? So the area mapped out is a rectangle. Right, so you can do it like that. So technically, it would be 1/5 by 2.1 plus 1.6. Right, so that's what, 3.7 divided by 5. 3.7 divided by 5. 3.7 divided by 5. Anybody got that? Okay, then which one are you not sure about? Which one, Jaden? Oh, yeah, you got two. 3.715. What? 3.7 divided by 0.74. All right, nice. Let's go again. This is 2016, right? Right after this, we get to do the exciting stuff, but we get to use the normal instrument. That would be here, right? Right, come with no food, right? So the first part of the proof, right? Yeah. Take your time online, right? You have to prove that, and then we go into the special continuous distribution, which we call the normal distribution, right? You didn't see.
Hi, excuse me, what's the function?
Oh, Yes. Yes. Thank you, all right.
Are you done? Right on nine, but some answers now before I start it. Bradley, give us some answers. Eden,
That's it.
Elena. Give me a few minutes again and I'm gonna start it. Okay, first time. But on the phone, eh? All right, I'll do it right here. Right, so they want us to show, that K is 1/7. What is total area here, Olivia? 1. So 1 is equal to one is equal to half the sum. Let's not put more right. Hold on, I'm gonna change color. One is equal to half the sum of the parallel side, so the parallel side 10 plus this side here, which is 4, and the height is k. Right? So a half of 14k is 7k. So k is 1/7. Right? That's it, right? That's basic stuff. And then they want the probability between 4 and 6. They want the probability between 4 and 6 now, right? So 4 is somewhere here. Let's find the area there, rectangle. Right? So it will be 2 by 1/7, which is 2/7.
So what?
So why do you,
Wow. Any function.
yeah, you get between. You gotta find the function is 1/7. But that's straight line. But I mean, the whole function,
Yeah.
well, it's different pieces. One function here, one function here.
That's why.
It's called a piecewise function.
Very soon.
Why, all you have to do, I tell you that we got think it,
How is it 2 times 1/7?
because it's between 4 and 6, the rectangle. Here's 2.
Was.
There are 4 is.
Oh. Oh. So. Yes, sir, that's what I was marked to put a song in our.
Anyway, that's stuff. All right. That's 2 marks now. You know, do the same thing in the.
Yeah.
For sure. All right, online, are you okay there? Or do I didn't get any answers?
Oh yes, I get you down. I finish the next part too.
But you didn't message any answers. How I know you get out. She didn't send anything. Alina didn't send anything. Well, let's do what I want outside it. All right. So those are the things that you need to know for the first part of continuous, right? You don't need to know cumulative distribution functions and things, right? Exponent, you don't need to know about variance and E of X in this unit. So what we're going on to now is this special. We're going on to a special distribution. That distribution is continuous and is what we call the normal distribution. All right. If you go back to the group chat, you will see I sent long ago a table with charts, right? So I can find it back. Check at the beginning somewhere, right? I sent this document here. Right? It has all these little tables and things. Today, we're just going to focus on how to read the normal distribution. Remember this?
Whoa.
Right. So we're going to focus on this distribution. That distribution is what we call the normal distribution. It's the beautiful distribution that makes life simple. Right? Here's what they say. What they say is that if we collect a large amount of data, thousands, millions, right? The data will shape out like this. Right? So for example, if I had to collect heights, right? A continuous something like heights. If I collect the heights of all the people in the world, it will shape off like this. Right? Or even in Trinidad, it will shape off like that. Right? So what I'm saying is, here's what it's saying. This normal distribution saying that everything functions around a mean value. Oh, this happened there, right? Hey, what just happened then?
Double tap.
It's up. Right, it's back. Right. So as I was saying, right? What you will recognize, ignore the 0 for now, right? what you will recognize, right, is that the normal distribution, right, that's the shape of it. And everything is basically symmetric around the mean, right? So let's just pretend that the mean height is, ignore the zero here. Let's say the mean height is 125 centimeters. What that means is that there are people who are shorter, that is short people. Then we have taller people here. Right? So it means that all the people everybody in the world basically could fit into this distribution. Right? If you're short, you're less than 1.25. If you're tall, you're more than 125. Okay? So that's technically what the distribution will look like. Right? Right. The area underneath this distribution, everywhere, if I were to find the area underneath there, that area is 1. Okay? So the area underneath that entire distribution there is 1. But here's the problem. If I were to do a normal distribution for male and a normal distribution for female, the heights will be the same, right? Sorry, the shape will be the same. But these values here for me will not be the same. The average height for a woman might be 110, and the average height for a man might be 125. So therefore, I will have to learn a whole set of distributions. So I don't want that stress. Here's what we can do. We can standardize it. We can standardize all the normal distributions to look like this. Right? We can standardize all the normal distributions to look like that. Right? And then you only have one table to learn. One table to read on. And that table looks like this. Right? It gives us inside here, that's all the possible probabilities from 0 all the way until think about 2.9 something, 2.99. Right? That gives us all the probabilities between 0 and that value down. All the values of probability. Are you okay with that? Yeah? That's just a little intro on the normal distribution, right? We do have to learn the function at this level. If we move on to do start something like actuarial science, something, you will have to learn the actual distribution, or the formula looks like that. Manipulate and get these values. Right? Nice. How do we read this table? Right? How do we read this table? So whenever we standardize, we're always going to use this level Z. So suppose I wanted to find the probability of Z is less than 0. Hold on, I'll tell you 0. Let me go too far. 0.42. Right? Let's see if we can find the probability of 0.42. So I want the probability of Z is less than 0.42. I want you to learn to shade and represent that probability on your diagram, right? So watch this here. This is my normal distribution. This is my 0 mark. So 0.42 has to be somewhere here. 0.42. I want the probability of less than 0.42. So I want this shaded region. Are you okay with that? Online, are you okay with that? I want to get that probability. Anybody okay with that online? Message yes or no, so I know you're paying attention. This is the most important thing, huh? I want the area underneath it. But you don't have to integrate it, you have to read out the table. Christopher said yes. Who else said yes? Who's have 5 yes? I have 3. Christopher said okay, Bradley said okay, Ian said okay. Nothing from Alina. Or the 2 young ladies doing very bad today. Nothing from Alina. Okay. Nothing from... Yeah. Okay, all right, now Elena. Very good. Nothing from Ravisha. Ravisha joined late and she's not even listening. She's not even paying attention.
So you want the answer to that, right?
What's that?
You want the answer to that, right?
Right, yeah, no, I'm gonna show you now.
Oh, okay. I was gonna tell you.
Just hoping we should pay attention. Always have hope there. One less hope in the world. Right, so what's it there? How do I read that off now? Oh, quick question. Based on what I shade, right? I want to see that probabilities on the left hand side here because it's symmetric, it's 0.5. All the probabilities here is also 0.5. Right? So the probability on either side of the line is 0.5. That's okay? Because remember it's symmetrical. And if the total is 1, well, it's half and half on the other side of the zero, right? Right. Jesse, what do you think, boy? You think that probability of Z is less than 0.42? Is more than 0.5 or less than 0.5? More than 0.5. Very good. So how do we read it off? From here, we look for 0.4, right? Remember it's 0.42, right? And you look for 2, where they intersect. That is the answer. 0.6628. But if you're not, of course, we are able to work in through this, right? Right. I have a little question for Mr. Jadon Haynes. Mr. Jadon Haynes, since the overall probability is 1, right? What do you think is the probability of Z is more than 0.42? More than 0.42. Our table only gave us less than, right? So let me see if Mr. Jadon Haynes can figure out what the probability of Z is more than 0.42. That's a more than symbol, eh? All right, anyone type it out to me? Jadon. Well done, Jadon. I like that, Jadon. So Jadon said 1 minus 0.6628. Right. Think out. Picking on it. Right? Very good, Jadon. That was impressive. I really smart. Very great. Are you okay with that? All right. So that's the way you read the table, right? That's the way you read the table. Any questions online? Except for Risha, who's not paying attention. Do me a favor now. Using the little snippet of the table I gave you there. Find the probability of Z. Might be a little hard for you to see, but I want more than. I want more than 0.31. Huh? Yeah. That's what that's. 3 and 1 is what I want to get. See if we can work out that now more than. Of course, work out the less than first, then we'll. Bradley, your mind minus in it, my place. What do you mean I'm saying? People I'm saying? It's one time. Or the ticket, or the to ticket to know.
What's the name of the symbol again?
What's the name of this symbol?
The Greek letter or whatever.
Right, so when you look it up, it's called I forget, phi or pi or shy. That's all. See if they hold on it. I actually forgot the name of this section. I think that's phi. Yeah, it's 5, so it's 5. So really and truly, what you have to read off is 5, that's the value from the table, 5 of 0.31 and then minus it. So it's minus 1 minus 5 of 0.31. 0.31 would have been boom, bada bing, somewhere here, somewhere here. So that's 1 minus 0.6217, which is 0.325.
Zero.
Go ahead, everyone.
0.3783.
0.3.
783.
I know the present, I do. Right. What are we gonna get Friday?
No.
Yeah, that's it.
No.
All right, nice. All right, I don't want to show you the harder ones as yet. All right, nice. Alina, you okay? You didn't message the value. Let me show you again, sure.
Oh, yeah, sir, yes, sir. See, I'm sorry, but right now I'm multitasking because I have a Caribbean exam in the morning, sir.
Okay, I have 2 minutes again, right? So just focus on mine for 2 minutes. And then I can let you go back to 30 minutes. For the send all the SBAs, right? I will turn over and for the end of the month. Yeah, we have the SBA. The school. You know, right, just one thing on the go. Right? What would have happened if I said, find the probability of, do I make this hard or easy, boy? Yeah. What to do about next? But anyway, suppose I said the probability of Z is less than minus 0.31. Let's see if we can work out that. Right? Real simple. Right? First thing I want you to do is catch it. And then in your mind, remember here is 0, right? That's done. Right, that's 0. Minus 0.31 will be on the left side. And I said less than minus 0.31 to be shading here. Right? What you will recognize now is that piece that I shade there is the same because it's symmetrical as shading 0.31 there. Right? So what I know my handwriting a little bad, but what I'm trying to say is this. The probability of Z is less than minus 0.3 is the same as the probability of Z is more than 0.31. Right? So because this normal distribution is symmetrical, right? Because it's symmetrical, those two problems are the same. Right? Because there is no negative on that chart I gave you. Right? So in order for you to work out this negative value, you have to do the same thing that you did here. 1 minus 5 of 0.31. Okay? And you have to get the same value as before. All right? So it's important we understand this because when we go further into this next stage, right, I'll show you how to handle negatives and between A and B and those little things, right? But I will stop there for today because Alina have an exam tomorrow and I want you to go and study.